So why do building simulation models give different answers?
Several reasons. You've got different people using it. You have different methodologies used within that simulation. You can have different what we call time steps of how coarse or how wide you look at a period of time. And you can actually put in to the same model and get different answers out of it. But you'll get differences because one's got a simplified approach to how it's dealing with the physics of it, and others go into more detail. And some people will put in it to a greater level of detail, information about people. They won't necessarily use the standard things, they know more about the subject. So you will get, real variations. And even if you do it following for something like compliance, if you use an SFM model, it is a simplified model. It's not like a TAS model or an IES model. It uses fundamentally different mathematics, and they might even deal with different ways of dealing with thermal bridges or different ways of dealing with air infiltration in the modelling. So it's not consistent within the models. They're all doing it slightly different way.
So what can we do to change that? What's the best direction to go in?
Well, you shouldn't ever want to sort of stifle innovation and getting people to do it in a better way, but you've also got to balance doing it in a better way with having the data and the availability of data to fill in the slots it would be asked for if you're going to do it in that level of detail. So you could say, are you prepared to have a simulation that lasts an hour? And if I did it in a lot more detail, for it to take 2 days to run. Mm-hmm. And to take 2 days, you might need to put in 20 times more data. So if you put in more data, you could also get errors because it's more likely to get a number wrong out of 20 than just assuming a smaller number of numbers and having it run quicker. But I would say standardization is perhaps needed when you're dealing with one set of compliance. You don't want one bit of software saying it passes, another one says it fails, because that gives you all sorts of arguments. And almost to get round that, the way they do it is don't give you absolutes, they give you comparisons within the same model, which actually minimises that difference. Whereas if you looked at the actual numbers for heating, cooling, they could be different, but overall they're likely to be closer if you do a comparator.
I see. And how can you strike the balance between saving energy and saving carbon?
I think that's a really good question, and the terms that we talk about compliance being conserving fuel and power, and when you think of fuel and power, that's about energy. And energy you might measure in kilowatt hours per square metre or in megajoules per square metre, but we've chosen to use CO2, and there's good reasons for that with Kyoto commitments, and our carbon commitments is a nation who want to get down to an 80% reduction over 1990 levels. So we've got carbon clearly on the agenda, and they use Part L and some of the compliance tools to target carbon. But actually you could have an energy wasteful building that passes a carbon target but uses a lot of energy. Now that is trying to be redressed to some extent now with where we're going to go with the next edition of SAP and what's happening with 2013 regs, to say it's not only about a target emission rate, but it's also about a fabric energy efficiency standard. So you can't just do it through, it'd be a bit like saying I've got a corrugated tin hut, I put a wood burning stove in it, it's got an awful fabric, it uses loads of energy, but because it's burning wood, it doesn't count because it's low carbon. We've got to get energy down first, and one thing you'd always guarantee, if you get the energy consumption down, by default you'll get the carbon down. But you can get the carbon right down but have a gas-guzzling building. Well, not necessarily gas, but it could be biogas then, or it could be something that's using a lot of energy. So we've got an energy inefficient building, we want it to pass Part L, so we put some solar thermal collectors, a bit of PV, and we put a biomass boiler in. Tick the box, we've got there, we've passed the carbon target. Is it low energy? Oh, it's using a lot of kilowatt hours per square metre, but it passed the carbon target. So work with energy first, and as a last resort, fine-tune on the carbon.